Hello, welcome to the third video in this series. Today we will talk about hexadecimal. Now, for full disclosure, hexadecimal is not formally tested on the AP Computer Science Principles exam, but I wanted to include anyways for completeness. Many AP Computer Science Principles classes across the world will indeed include a, um, a unit on hexadecimal. So if you look here, this is what hexadecimal looks like. These are a bunch of two-digit hexadecimal numbers. You see here, this is 4E, this is 54. Notice I did not say 54. This is C2, etc. Right? So if binary is base 2, decimal, aka denary, is base 10, what is hexadecimal? Well, if you look here, hexa means what? 6. Deci means what? 10. Add the two of them together, and what do you get? 16. So again, I'll ask you, hexadecimal is base what? That's right, it's base 16. So there are a total of 16 hexadecimal digits. What are they? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So far, it looks just like regular decimal numbers, right? Well, what comes afterwards? After 9, we get A, B, C, D, E, F. So are you wondering, why do we do A, B, C, D, E, F? Well, for the computer, how do you tell if it's 10 or 1 and 0? So 11 looks like two ones, 12 looks just like 1 and 2, etc. So hexadecimal, we use A, B, C, D, E, F to avoid confusion and any ambiguity. So let's start with just two digits in hexadecimal. Let's start with 2B. So B is the same as what? So A is the same as 10, B is the same as 11. All we have to do is take this, multiply it by this. 2 times 16 is equal to what? 32. B is what? So B times 1, which is equal to 11 times 1, which is equal to just 11. Then we add these two numbers. 32 plus 11 gives you 43. So remember, in binary, we were doing base 2, starting 2 to the 0th power, 2 to the first power, then 2 to the second power, and so forth. Here it's the same thing. This is 16 to the 0 power, and this is 16 to the first power, right? So if you look back, this is 10, 11, 12, 13, 14, and 15. So 15 is F, which is the highest number in hexadecimal, or single digits at least. So in an actual live classroom, I would ask you to give me some together so that we could do them together. But since we can't do that, I'll just make one up. How about 7F? Right, well, this is the 16 to the first power column. This is the 16 to the 0 power column. 7 times 16 plus, what's F? F is 15. 15 times 16 to the 0 power, which is what? 1. So then we get 7 times 16, which is what? 112 plus 15, which becomes 127. Your turn. Calculate all of these in decimal. So pause the video right now to calculate them in decimal. All right, so assuming you did that, the answers are 59, 180, 124, and 0. Some quick questions for you. Does a hexadecimal number always have to have a letter? No, it doesn't. For example, 1 1 could be hexadecimal, or A3, which does have a letter, or 7 2. What is the largest hexadecimal number you can write with 2 digits? And what is its decimal value? So if you look here, dun 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 dun, 2 hexadecimal digits. What's the largest hexadecimal digit? F. So again, what's the other largest hexadecimal digit? F. So it becomes FF. Now, let's convert FF to decimal. What is the decimal value? Well, F is 15, and F is also 15. This is the 16 to the 0 power column. This is the 16 to the first power column. So we end up getting 15 times 16 plus 15 times 1, which gives us 240 plus 15, which gives us 255. Does that number look familiar? Have you seen it somewhere else before? In fact, in a previous video, you learned that in 8-bit, for 1 byte, the highest number represented is 255. If you somehow forget that hexadecimal is base 16, how can you use the word hexadecimal itself to help you remember? Well, hexa means 6 and deci means 10. All right, phew, that was with 2 digits. Now, let's go with longer hexadecimal numbers. A lot of time you'll need to deal with 2, but sometimes you'll need to deal with longer ones. So fortunately, it's not that much harder. So let's try this one. 1A00. Well, the 00s will be quite easy. So if you look here, this is 16 to the 0 power. This is 16 to the first power, 16 to the second power, 16 to the third power, right? Let's start here. 1 times 4096 gives you what? That's right, 4096. Now, 16 squared is 256. A is equal to what? 10. So 10 times 256 is equal to 2560. Well, 0 times anything is just 0, and 0 times anything is just 0. So add these numbers together. What do you get? 6,656. Okay, so let's do another one together. Give me any 4-digit hexadecimal number. Since I'm the only one here during this video recording, I'll make it up myself. How about 2B 3A? So 2 times 4096 gives you what? 8,192. Feel free to check my math. I'm doing this in my head without a calculator. So next, B is equal to what? That's right, 11. So 11 times 256, which gives you what? So I'll bust out my calculator for this one. 2,816 3 times 16 gives you 3 times 16 gives you 48. And then 8 is equal to what? 10. 10 times 1 gives you 10. So add these together, and there's no way I'm going to be able to do that in my head. So I'm going to use a calculator. 8192 plus 2816 plus 48 plus 10. Looks like this is 11,066 in decimal. Your turn. So figure these on your own. Remember, this is not 1111. Oh, by the way, 0x just means the hexadecimal. Because for the computer, how do you know if this is decimal or hexadecimal? So you write 0x. This does not mean 0 times 25 is 0x, which means hexadecimal is coming up. This is 25, not 25. Same thing for here, 0x 11. Well, is this 1111 in decimal? Is it 11 in binary, or is it 11 in hexadecimal? Hard to tell. So we have this just to indicate hexadecimal. Right? So go pause the video and figure these three out. I'll be waiting. Back. So here are the answers. 4,369, 9,631, 602. Did you get all three of them right? So next topic is converting from decimal to hexadecimal. Luckily, this is quite easy. For decimal numbers up to 255, take any decimal number, for example, 87. Divide it by 16. So 87 divided by 16 gives you what? Gives you 5 with a remainder of 7. Then take 7 divided by 1, which gives you 7 with a remainder of 0. And that's it. It becomes 57. Remember, please don't say 57. So note, usually in computer science, capital letters versus lowercase letters, that makes a difference. In hexadecimal, it doesn't really matter. I will accept either uppercase or lowercase, but be consistent. So I don't want to see half uppercase, half lowercase in your answers, right? So more about decimal to hexadecimal. What if we took numbers, so if we take numbers up to 255, divide it by 16, that result goes in the 16s column. The remainder goes in the units column. So again, let's look at 59 as an example. 59 divided by 16 gives you 3 with a remainder of 11, which means 3B is our answer. Let's try one together. Can someone give me a number? Well, since this is a pre-recorded video, how about 119? So what is 119 in hexadecimal? Divided by 16 gives us what? I think 7, is that right? Yes, I think so. With a remainder of 7. Well, would you look at that? 7 divided by 1 gives you 7 with a remainder of 0. Looks like 119 is just 7 in hexadecimal, 0x77. So to make sure I'm not wrong, I'm going to use my calculator real quick. Okay, so it's correct. Your turn. Again, pause this video and figure these out on your own. I'll be back, or I'll be waiting for you. Did you pause and finish? All right. The answers are 35, 6E04. Great job. So, how do we convert larger hexadecimals or larger decimal numbers into hexadecimal? Again, not that easy, but I recommend having a calculator with you. So if you have numbers greater than 255, you'll need to use the larger hexadecimal column values. So take a number such as 602. Find the largest column that is smaller than 602, the decimal number. So in this case, it's 256. 602 divided by 256 is 2 with a remainder of 90. Divide 90 by the next column value, which is 16. We get 5 with a remainder of 10. And then 10 is equal to A. So the hexadecimal with 4 hexadecimal digits is 025A. So remember, each column looks like this: 16 to the 0 power, 16 to the first power, 16 to the second power, 16 to the third power, right? So 025A. Feel free to check my work. Let's try one together. So give me a big number. Well, since no one's here, I'll give myself a random number. 32,199. So obviously it's divisible by 4086. So let's try it. 32,000 divided 2,190, 4096. We get 7 with a remainder of, give me 1 second to calculate 4096 times 7. With a remainder of 3,527. Right, so here's a new number to work with. 3,527 divided by 256 gives you 13 with a remainder of 256 times 13. With a remainder of 199. Right? So that's a new number to work with. 199 divided by 16 gives you, is it 12? I think it's 12, so 16 times. Yes, 12 with a remainder of 7. So 7's the last one. So it looks like this: 7, 12. What's 12 again? B. No, C, sorry. C. 13 is D. And over in front we have 7. So the answer is 7DC7. Your turn. Figure these ones out in hexadecimal. Again, pause the video and figure it out. The answers are 212, 44C, and 8C13. Did you get them all right? It's starting to get a little bit more challenging, isn't it? So how do we convert from hexadecimal to binary and from binary to hexadecimal? This is very, very easy to do. Notice we can separate binary numbers into groups of 4. Do you remember what 4 bits is called? It's called a nibble. So if you notice, 0101, 1010 is the same as 0101 for the upper 4 bits, and then 1010 for the lower 4 bits. So what is 0101 in decimal? That's 5. What is 1010 in decimal? It's 10. What's 10 in decimal or hexadecimal? It's A. So the answer is 5A. Let's do some together. Let's make an 8-bit binary number and convert it to hexadecimal. Since I'm the only one here, let's try it. 1, 0, 0, 1, 0, 0, 1, 1. We can split it into two. 1, 0, 0, 1 is what in hexadecimal? It's 9. And then 0, 0, 1, 1, that's what? 3. And that's it. You can do this for binary numbers of any length. Here, for example, we have 12 bits. Again, same pattern. Break into 4 here, break into 4 here, and break into 4 here. Ta-da! So from here, it's quite easy. This is 10. This is 7. And this is 8. So it'll be A7, 8. Now do these on your own. Remember, it's quite easy. All you gotta do is this. Do, do, do. So go pause the video and I'll be waiting for you to come back. Finished. So the answers are CCC and F0F and 2AA. Are you wondering, what if we have an odd number of bits? For example, 7 bits or any other number that's not divisible by 4? No problem. We'll just add some leading zeros to the front of the number until it is divisible by 4. So for example, if you had 0, 1, 0, 1, 1, 1, 0, well, that's 7 bits, right? Just add a new bit of 0 to the front. So how about hexadecimal 2 binary? Well, it's even easier. Just take the 2 or however many hexadecimal numbers, for instance 9b, and separate them. 9 and 11. What's 9 in hexadecimal? 4-bit or what's 9 in 4-bit binary? 1, 0, 0, 1. What's 11 in 4-bit binary? 1, 0, 1, 1. And we're done. So can you give me one? Let's do one together. So if you take any hexadecimal number, so for example, A4, 5, A is 10, so 1, 0, 1, 0. 4 is 0, 1, 0, 0. 5 is 0, 1, 0, 1. And that's it. We are done. So do these ones on your own. Go ahead and pause this video now. So here are the answers. Double check them. How many did you get right? So that is all for today. Thank you very much, and I'll see you in the next video. Bye-bye.